So in this video we are going to solve a few problems involving solid geometry. So by this time I assume that you have already seen all the lessons of solid geometry involving different shapes, and you are familiar with the theorem, the formula, the properties of different shapes like sphere, pyramids, rectangular solids, sphere, and cylinders. So let's try with let's start solving some problems with some basic shapes. So let's take rectangular solids. So let's first draw a rectangular solid here. So here is a rectangular solid. Now one type of problem could be involving finding diagonals. So you may be given volume or a surface area, and from there you have to find the different dimensions, and using those dimensions you would be finding the diagonal. So one such problem could be, let's say if you assume this is a cube, and if you're given the area of the cube. So let's say if you're given area of the cube is 27 centimeter cube, and you have to find out what is the diagonal. Now you can say what is the long diagonal, or it could be given a fancy way of saying that what is the distance from one corner to the furthest corner, or could be what is the longest line you could draw within the cube. So there are three ways of expressing. So because this long diagonal is sort of the longest line, and it or it could be say that which is the longest diagonal in the cube. So to do that, first let's I'm sorry, again I did a mistake. It should be volume. So the volume of the cube is 27 centimeter cube. Find the longest diagonal. So we know the volume of the cube is s cube, where s is the length of each side. So this would lead to s equal to root 3 27, that it equal to 3. So each side is 3. So s equals to 3 centimeter. Now the longest diagonal, if you remember, we did the formula where the longest diagonal is s root 3. So that would lead to the longest diagonal is 3 times root 3. So this is your answer. If you remember, the way we found out the longest diagonal is we found the diagonal of this, and then we, using the Pythagorean theorem of this triangle, we found the longest diagonal. So our answer is 3 root 3. Now the second problem, let's say we may be given a rectangular solid of similar nature, and then find out how many different cubes you can make out of it. So let's draw another rectangular solid first. So I'm going to draw another rectangular solid, let's say. And let's assume this is also another cube, and each of length it could be given 4, or you could be told that the area of or the volume of the cube is 4, and the problem is how many smaller cubes you can cut out of it. So let's say each of these smaller cubes, if you can cut this cube into several smaller cubes, each of them length 1 centimeter, So this is 1. So how many pieces of cube will that be? So let me state the problem again. You are given a cube with 4 centimeter. How many cubes you can make out of this, each having length of 1 centimeter? So you can think like this. So you're making several cubes out of this cube. So now one way to solve the problem is through just volume. So the volume of the cube is 4 cube, the bigger cube, equal to 64 centimeter square or centimeter cube. This is the volume of bigger cube, and the volume of smaller cube is, which are 1 centimeter. 1 centimeter is 1 cube equals to 1. So that means if you cut all the smaller cubes, all of them together, the volume of each of the pieces together will make the bigger cube. So you can think if the number of cubes is n times the volume of smaller cubes, so let's say that is volume 1, equal to the volume of the bigger cube, which is, let's say, volume. So then n becomes, so the number of cubes which you can make out of this bigger cube is the ratio of the volumes, which is 64 times 1, which is 64. So you can make 64 smaller cubes out of this bigger cube. Now you can also have a different twist of the problem. You can be another variation of the problem, or another little bit twist of the problem, is you can be told that you're given a bigger cube and you paint the cube on all its surfaces, and then try to cut the cube into smaller pieces with having length 1 centimeter on each side of the smaller sides. So you can be told, now find out how many smaller cubes has exactly one face painted. So let me repeat the problem again. You're given a cube with 4 centimeter. You are painting the side of all the sides of the cube, and then you're cutting the cubes into smaller pieces of 1 centimeter length each of its side. How many of those smaller cubes will have only one side colored or one side painted? Now, to solve this problem, so let's say this is 4. You have to try to visualize how many cubes on each surface will have exactly one side painted. So let me draw a little bit of bigger. So let's assume this is one surface of the cube. And let me choose a different color. And then if you think these are the smaller cubes. So this is, if this is 4, so you can think each of this is, there would be 4 such cubes. So if you just take one surface, this would have one surface painted. So this one will have 2 surface painted. So only the inner 4 would have only one surface painted. So if you see the smaller cubes which belong to the edges, so each of these cubes will have 2 surface painted, but the inner cubes will have only one surface painted. So that means each side, each surface or each side of the cube would produce 4 such cubes which will have just only one surface painted. So let me choose a different color to denote those. So these 4 will have one surface painted. So that means if now we have considered only one surface of the cube, so that is, and one surface of the cube produces 4 such smaller cubes which have one surface painted. So like that, if you have 6 surfaces, then you will have 24 such cubes which will have exactly one surface painted. So if you can try to visualize the cube, this problem would be a little bit easier to comprehend. Thank you.